In this lecture, we will see the M-way search trees. So generally in binary search tree, every node contains two pointers, that is one left pointer and one right pointer. So M-way search trees based on this concept only. So for a M-way search tree, it contains, that is every node in the M-way search tree contains m-1 values and m subtrees, and m is called the degree of the tree. For example, if m is equal to 2, it has one value and two subtrees. Okay, for example, if m is equal to 3, it has at most two values and three subtrees. Okay, so the structure of the M-way search tree is like this. So we have pointers and keys. So P0, P1, P2, P3 and so on, Pn minus 1 are the pointers, and K0, K1 and so on, K2 are the key values. Generally, these key values are arranged in the ascending order. That is, K0 is less than, K1 less than, K2 less than and so on, Kn minus 1. So we'll see a few more examples. So this is an M-way tree of order 3. So it is having m minus 1 values, that is 3 minus 1, 2 values. That is every node contains at most 2 values, and it has at most 3 subtrees. Okay, m subtrees. Similarly, this is an example of M-way tree of order 4, where every node contains at most m minus 1 values, that is 3 values, and 4 subtrees, that is the maximum number. That is, every node should contain 1, 2, 3 values. That means at most m minus 1 values, that is at most 3 values. That is, it should contain either 1, 2 or 3 values, and at most that is m subtrees, that is 4 subtrees. So we'll see B-trees. So this is a special M-way search tree. It was developed by Rudolf Baer and McCreight in 1970. Okay, so generally these B-trees are used for disk access. So why we are using B-trees is, using B-trees we can store large number of keys in a single node, so that the height of the tree will be small. So that means the tree will be bushy. So that means very less number of levels. Hence, the operations like insertion, deletion, search operations have a logarithmic amortized time. So that means amortized time in the sense, the sequence of operations on an average, it takes less time. Okay, individually each operation on a worst case it takes more time, but when you are doing a sequence of operations on an average, worst case worst case average time will be less. So that is the advantage of B trees. Next, we'll see the properties of B trees. So every node in the B tree at most should have m children. And the other property is, every node in the B tree except the root node or leaf nodes has at least m by 2 children. Okay, so this condition, so that's what I told in the previous slide also. The tree will be bushy, that is the height of the tree will be less. So that's the advantage of the B trees. It stores a lot of data in a single node. So what is the main property of a B tree is, it should have a maximum of m children, and it should have at least m by 2 children for every node other than the root node and leaf nodes. And next thing is, the root node has at least 2 children if it is not a terminal node. If it is not a leaf node, the root node should have at least, that is minimum 2 children and maximum of m children. Okay, so all leaf nodes are at the same level. So these 4 properties the B tree should satisfy. If any one of the property is not satisfied by a tree, then it is not a B tree. So we'll see one example. So this is a B tree of order 4. So that means according to the first property, it should have maximum of 4 children. Maximum of 4 children, and And for leaf nodes, you don't have any children, that is 0, right? So maximum of 4 children means 0, 1, 2, 3, 4, at most 4 children. Next thing is, see, in this tree, every node is having the root node. This node is having 2 children, and this node you have 3 children, and this node we have 3 children, right? So first property is satisfied in this example. Next thing is, every node in a B tree except the root node and leaf nodes has at least m by 2. So that is, as this B tree is of order 4, m by 2 means 4 by 2, that is 2. So minimum of 2 nodes should be there, that is 2 children should be there for every node, that is except root node and leaf node. So that is, if we leave this root node and leaf nodes, the middle level, you should have a minimum of m by 2 children, that is minimum of 2 children. So this node is having 3 and this node is having 3. So second property is also satisfied. Now coming to the third property, the root node has at least 2 children, so that is minimum 2 children it should have. So in this case, the 45 is the root node and it is having 2 children. So third property is satisfied, and all leaf nodes are at the same level. So all the leaf nodes are at the same level. So all the 4 properties are satisfied by this B tree, by this tree. Hence, this is a B tree of order 4. Next.